Hello, boys and girls. I am here with my co-host for today, Bart Kay. Uh, Hello. Okay. And I'm a big watcher slash fan slash follower of his YouTube channel and Patreon. In fact, if you've watched some of my videos, you've probably seen me mention him a couple times or link to his Patreon. So I have the man himself on, and today we're going to be talking about how nutritional science either flat out tries to manipulate you or flat out lies to you. Okay, and we're going to be showing some evidence of that. So, hello, Bart.
Hey, how you doing?
Good. So, Bart, just for the folks who don't know, he's in New Zealand, and so we're on opposite sides of the world. Not that that matters, but and Bart has. I know I said I want to do an intro, but just briefly, you were a senior lecturer in London, I believe.
Further north, yeah.
The north, okay, in the UK.
North. Yeah.
And your kind of background is in, if I have it correct, exercise physiology and cardiology, right?
Yeah, that's right. Yeah.
All right. And for the rugby fans out there, consultant for the New Zealand All Blacks, and published quite a few papers. If you Google Bart Kay, Google Scholar, you'll find some of his papers on there. So I'm really excited to have him on. So I just did the intro for him, a quick intro. Bart, I want to show you a tweet that I read today. This is the tweet. So there's this famous American football player. His name's Joe Thomas, and he's largely ketogenic. And somebody responded to his tweet, and as you can see, he has some bacon here, right?
Yep.
And it says, pork has been proven to be the leading cause of prostate cancer.
Yeah.
The leading cancer causer in men. Okay. Not sure why you want to brag about eating it, but remember this picture 20 to 30 years from now with 8 likes and 2 retweets. But yet 68 comments. So which I find happy because I would imagine people were destroying this. And I just put my own comment and it says causes and with some laughter. Okay. All right. So that's what we're going to be talking about because this poor man, Iceman, I don't even blame him because if you think about it, he's probably been lied to his whole life by the same garbage. So what I'm going to do is stop sharing here. Okay. And Bart, I know you had a couple studies which you wanted to show, but maybe take it away with the first one. Yes.
Good. Okay. So I've got a couple of studies that I sort of came to my mind immediately when Troy asked me to do this discussion. It's really interesting when you see comments written by people that say science, nutritional science, that is, has proven this, that, or the other thing. Like it's been, proven that pork is whatever the hell that thing said. Science is actually an experimental observation. It's not just an observation. So in order for you to say I've been doing science or science that I'm doing is proving or showing or even inferring anything, is you have to do an experimentally designed study. And what that requires you to do is control all factors affecting the outcome of interest except one, which you then manipulate upwards or downwards in one group with respect to another group or multiple groups with respect to each other. And you then measure the effect on that signal variable that you're looking for, be that the loss in weight over 6 months on a certain diet, be that the effectiveness of a given drug or whatever it is. And then what you would do is before you start doing that study, you would split a population of individuals who were ideally identical twins, and then you'd split the population in half, and one half of the twins gets treatment and then placebo with a washout period in the middle. The other half of the people get placebo and then treatment, so it's called a random order crossover trial. That eliminates the effects of one treatment on the other, and it eliminates, and as I say, you spend all this money and you undertake all these strict controls of all these factors, and then you get some outcome data that you can then assert with a certain degree of statistical confidence is the data set that is not due to random chance, and it was due to the direct causal effect of that one thing that you manipulated, everything else controlled. Yeah.
Right.
So that's science.
Mm-hmm.
Okay, that's manipulating, that's controlling everything, that's observing carefully. That's an experimental random order crossover trial. So if you want to say the science is settled, I want to see a random order crossover trial that is well designed, internally and externally valid, with huge statistical power, meaning a large sample size. And I'm going to want to see a massive effect size, which is a measure of how much the value of the signal has moved with respect to its baseline after all that crossover stuff is thrown into a chart and we've done all the funky math on it.
Right.
So that's what I want to see for settled science, Troy. So what I'm suggesting is it's neither ethical, possible, financially viable. It's just there's no way we are ever going to do actual science in nutrition. So the very idea of there being a branch of science called nutrition science for human beings is fundamentally ridiculous. There's no such thing. What we have is a bunch of studies which are associative studies. They come from a gambit of more abstract, less controlled experimental sciences, and they are more associative sciences where they look at the associations between factors, really, is what it is. So this is an example here. Nobody is being experimentally manipulated in any way by these researchers. Okay, so this is not a scientific research in the sense of this is not an experiment. So this is not proving anything. This is associating one thing with another and saying these things are linked in space and time together. They are happening together. It does not get to causality. It can never get to causality. It can never test or even suggest causality. It is an association. Okay?
Right.
So that's what we're relying on to make inferences to talk about this settled nutritional science that we have. And, you know, the first example that always comes to mind is the Siri-Torino paper, which I have here, because this is a comprehensive meta-analysis of all the well-designed, fairly powerful studies ever undertaken in terms of asking people what they ate over their lifespans, writing down what they said they ate, believing them completely, taking that back to a lab and associating what they tell us their diet has been over their lifespan with a diagnosable outcome, an illness outcome, in this case, cardiovascular diseases. So that's what they did. They got a bunch of people and they said, so how much saturated fat do you eat? And the people told them X, Y, and Z. They did that by a 66-item food frequency questionnaire. How often do you eat apples? How often do you eat pears? How often do you eat red meat? Blah, 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 cheese, blah, 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 blah. Okay, so they got this kind of gross, coarse, wildly invalid marker, I guess, with a massive standard deviation around it in terms of its variability to a 95% confidence level of where the average would be for the general population if you extrapolated the study out to everybody. Right. So you've got this thing. So what the suggestion has been, obviously, that everybody has probably heard, and if you haven't, where have you been? People will say, you know, saturated fat is associated with cardiovascular disease. You need to avoid saturated fat for that reason. The problems being that any association that did exist between saturated fat and heart disease could not be established as causal via these associative studies. And the second problem is that this meta-analysis done here by Patty Siri-Torino and her colleagues a few years ago was that, in fact, there is no association actually evident in the first instance.
Right.
So this is a study of 347, nearly 348,000 subjects across a number of different investigations done by different authors, where basically they have asked people, what is it that you eat, using these questionnaires, and associated that diet with these cardiovascular disease process outcomes, I guess.
Mm-hmm.
And then you split people into bin groups, if you like, of usually quartiles of saturated fat intake, and then you take the sample, the population, your subpopulation with the lowest amount versus your population with the highest amount of saturated fat intake, and you look at the incidence in those two populations, and then you make all sorts of wild inferences and statements about this, absolutely proving that these two things are causally related and that you should avoid one of them on the basis of any connection between the two factors you might find. So out of all of that, we would suspect that because we were always told that saturated fat is associated with heart disease. So my first point is, okay, fine, not causal. My second point is, well, actually, is it? And I guess that's what this paper here shows us. No, it isn't so, actually. So if we look at the primary outcome chart here, these are the summaries of the effect sizes that you're seeing in all the individual studies, with the 95% confidence intervals, the straight lines horizontally from the dots. And the size of the dot is showing us pretty much how much weight that study had within the overall result based on the sample size involved. Mm-hmm. So basically that's what we're looking at here. So, Shikeli and colleagues found that in the 1/5 of their population who ate the most saturated fat, there was an 11% increase in cardiovascular events. Mm-hmm. In that population of whatever size pool that was, 1981 that was done. The 95% confidence around the value found in that study suggests that the true population would be somewhere between 0.91 and 1.36 in terms of a relative risk factor. And I'll get to relative versus absolute later, Troy, but in the meantime, it's just to say, it's a percentage increase in risk is what they're talking about. Mm-hmm. And then, so obviously you take this study done here in 1981, there's another one in 84, another one in 85, another one in 91, 93, etc. They're in chronological order by the looks on this chart. And it does a mishmash, it does a synthesis of the whole lot and gives us an overall result plus or minus a confidence interval around that result, which is supposedly more accurate than any one of the smaller samples above it, because it's obviously takes their grand number of observations as its baseline and therefore is more representative of the general population, so is closer to what the real result would be. That's the idea of a meta-analysis. And what we get here with the coincidence between eating more saturated fat and having more heart disease is a 7% increase in heart disease in the highest saturated fat intake, and with 95 confidence saying actually it might be under 100%, it might be a 96% as many heart disease results. So it might actually be that saturated fat actually could, in the true population, be protective and not associated with a problem. Or it might be as high as 20% higher. So anywhere between 4% less and 19% more is what we can assert out to the population on the basis of this 347,000 patient study. That's the kind of work that people base these claims on. Oh, look, saturated fat is clearly associated with risk. Sure, it's a small effect, but it's over such a large population that we are pretty certain that it's not due to chance, although we have no idea whether it's causal or not. So let's just avoid that, basically. So that's coronary heart disease. They've got another analysis here for strokes, which shows that strokes very clearly go down in the higher fat population. They have a 19% lower risk, anywhere between 38 and 1%, 5% less. So overall, cardiovascular and cerebrovascular events associated with saturated fat. Therefore, the synthesis comes out, the risk in the population which ate the most saturated fat as compared to the group that ate the least saturated fat, 1.00. The same incidence.
Right.
Overall. Confidence anywhere between 11% lower and 11% higher. But the middle of that range falls straight on 1.00. Same risk. There is no association between saturated fat and cerebrovascular cardiovascular disease.
So this, what I love about this is it's using what they love to use, which is these associative studies, which is not actual science. Then they use these studies to try to prove their point.
Yeah.
Meanwhile, even if this meta-analysis is basically combining all of their studies and showing, even with their own studies, that it's not showing anything.
That's right.
So that's it's great. I love it.
This work basically tells us nothing to see here, as to, if you were asked to report home on whether people who report on a survey that they eat more saturated fat than those who report they eat less, no difference. Good. Okay, so that's the science on which we are basing our avoidance of saturated fat. So that's the first example of poor science being used to mislead us. So when people say the science is clear and saturated fat is associated with heart disease, you can all now confidently stand up and say, sorry, neither of those statements is true. It is, neither is the science settled, because there isn't any. There's only an associative study. And secondly, it doesn't show an association in the first place.
Right.
So forget the whole idea, basically. While this research design is not capable of informing on mechanisms and saying one thing is causal, it is, by its failure to do so, capable of informing us that the two things are not causally related.
Right.
So it does have that power, and it has done that right here. So that's my take on that. Anyway, so that's paper number 1. Another interesting paper, a more recent paper, sure. This is a paper that associates, again, this is an association between, again, what people say they've been eating on a survey, I guess, basically, or a 66-item questionnaire, if you want to get technical. And this one talks about red and processed meat, as if they're the same thing, by the way, with all-cause cardiovascular and cancer mortality. So if you eat more red meat, or at least tell us you do, are you more likely to suffer from heart disease, cancer, or in fact to die for any reason whatsoever, even if that's being run over by a bus?
Right.
Okay, so interesting things. It goes through the study. It talks about the study design, as these things are required to do in the papers here. How did we select our population? What was our randomization, seed, blah, blah, etc., etc. Who did we include? Who did we exclude? Why did we do that? We did an analysis to show that our statistics were sensitive enough to find a signal in amongst what's basically massive noise. Good. It repeats on all that stuff, and then it comes back and says, right, well, so here's what we've got in terms of the different studies, different models and things, and results that come out of it. These are 1 versus 2, 3, and 4 quartiles. So let's split these populations into fourths rather than fifths. And they're just comparing, for example, what's the difference in this case between the first quartile of red meat and processed meat consumption, and the fourth quartile, so the highest versus the lowest again. And here we've got a 1.712 rate of event, meaning that there are 71% more events in the fourth quartile than the first, in what's called a relative risk ratio, which is what I want to talk to you about, and is the point of bringing this paper up here. You see numbers here between 13% or 1.13 increase between the first and second. The first and third is a bit more, the first and fourth. So you've got this kind of dose response here in terms of this associative result. And you go, oh, 71% more by the time you get to the fourth quartile with respect to the first. That would be enough to concern anybody, wouldn't it?
Yeah, sure.
Or should be, really, until you understand what a relative risk ratio is. Okay. Let me give you an example using some completely hypothetical math. This is the same math I've used, I don't know how many times on my channel, so people have heard this before, forgive me, but it's the best one I can come up with. If I collect a sample together, I select 1 million participants who are going to take my experimental drug in my research design, and I've got 1 million participants who are not going to take that drug, they're going to get a placebo, and I start at the beginning of my observation period and I follow these people for 20 years, and I've got 1 million times 20 years is 20 million person years of follow-up, therefore, in each of two groups. So in total, I've got 40 million person years of follow-up. Let's say my experimental group that I was following had one event of the disease process I'm interested in, and on the right, in my placebo group, there were 2 incidences diagnosed of that disease process in my 20 years of follow-up. What I can now say is this. With a sample size which is ridiculously huge, so therefore the statistical confidence around my result is exceedingly high, and therefore it's likely to be a real thing, I can say to the reviewer of this journal, I have found over 40 million person years of follow-up that the risk increases in the group that did not get my magical experimental intervention by 100%.
Because it went from 1 to 2.
That's right.
Yeah.
It's a 100% increase in relative risk. And that is mathematically absolutely unchallengeable. It's an entirely appropriate statement. However, in terms of its utility as information for us on which we should base decisions around how we should live our lives, it's worthless.
Yeah.
Completely worthless, because the relative risk gives us no gauge on the absolute numbers of people suffering these disease processes. If you did the math in terms of saying, rather than as a relative risk, I want to know what the absolute change in risk is, you would say, well, the change in risk is 1 over 40 million person years. Or as a decimal, 0.2 many zeros to even bother throwing out. Yeah?
Right.
So as an incidence change per one individual, the odds of the outcome changing in that one individual are 0.00000 blah 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 blah, more 0.000 blah 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 0.000. Finished. Okay, I'm exaggerating and I'm being flippant on purpose, but that's what the issue is with a lot of this research, and this is how it's misleading us by saying, please, Mr. Editor, publish my work that says your risk will go up by 70% if you eat more red meat. And I mean, my first question, having read this study, would be, great, let's go to the part of this paper where it tells us what the number of events were. so that we can get a gauge on the absolute change in risk that I can expect as an individual if I was to cut out meat. And even then, it's an association, remember, it's not a causal thing. So me changing my diet on the basis of this association has a higher probability that it will have no impact on the outcome at the end of my 40 years or 20 years. But let's just say for some fluke reason, the two things are causally related, and a reduction in red meat would result in a lower risk for me. How much is that? Let's get a gauge on it, shall we? So I was looking around this paper going, right, so yeah, there's some relative risk factors here. You have to come down to a table like this where it talks about the absolute sort of numbers.
Mm-hmm.
So what we've got here is all-cause mortality, so dying for any reason, whether that's being run over by a bus, hit by lightning, or dying of cancer or anything else.
Right.
If you eat more red meat, then the risk is that you would have more events. And so what we've got here is 248,554 participants. And then it needs to tell us how many years average follow-up per participant so that we can multiply that out to get our person years of follow-up, which they haven't even provided here, so we can't do it. Right. But let's say it's just to make the math easy and just to impose something, let's say they followed for 10 years.
Okay.
So that just makes it 2,400,000, let's call it 2.5 million years, 2.5 million person years of follow-up. Are you with me?
Yeah.
Make sense? Okay, yes. Cool. Right, so down here we've got a total of 6,171 deaths. And then we have to use this ratio to back generate the actual, and split it into what the differences were.
Mm-hmm.
And the change in risk in this case was 4%.
Okay.
So you need basically to split the 6,171 in half, and then take 2% from one team and put it on the other team of that. So you're looking at probably a difference here, just to roughly the math in my head, of less than 20 deaths by any reason, including cancers, heart disease, and whatever else, over 2.5 million person years of follow-up. So divide 2.5 million, divide 20 by 2.5 million, and that is the change in risk metric for any one given individual.
Yeah. So that's
the change in risk is the absolute risk is so close to zero, the difference makes absolutely no useful change in anybody's life outcome, outlook, lifespan, health, fitness, anything.
And what's incredible about this is that, I think people generally are trusting of one another, particularly of, I don't know, I think people are becoming less and less trusting of the government, especially since the internet. But overall, I would say, the government tells them something, or the scientists tell them something, people just trust it because they don't have anything to do with it in their normal lives, right? So it's like, that's what they get paid to do, so they know the best, so I'll just listen to them. So
that's right.
I used to be that way too, so it's not like I'm confused of why that exists that way. But I will say this. One, we have the empirical process, which is what the scientific method is, right? Which we talked about at the beginning, which is you run an experiment, you have a hypothesis, you run an actual controlled experiment, you see the results, and then you pivot and you go from there, right? Yeah. Versus associative studies, which is basically somebody sending surveys out to people, what did you eat over the last 10 years? And using that as some kind of causal data, which it's obviously not, because even if you could, that doesn't take into consideration the fact that when you had a hamburger, you had it with bread and probably French fries and soda, but
Yep.
yet they're only considering the meat portion of it, okay? Even in the associative studies. And then then they'll use on top of that, so they're already using all this junk science, which is totally meaningless. And on top of that, what they will do is then manipulate that data to say, oh, the risk is increased by 50%, right? Which Bart just showed you how that it's absolute nonsense, right? So this is some of the ways which, if you're sitting at home watching the local news, and they have I see this all the time on the local news. They'll just come up and says, new study, eggs increase the risk of heart attack by 20% or whatever. Whenever you see a study like that, that's exactly the type of study we're talking about. It is not actual science. And on top of being not actual science, it's actually misleading results anyway.
Yes, with malice aforethought too, Troy. At the end of the day, this is a branch of former scientists, the epidemiologists, I mean. They are a branch of former scientists who went, you know what? I don't think I can be doing science anymore. Can you? Nah, it's expensive and you have to do ethics. Tell you what, instead of actually intervening and having to answer for our actions to provide some actual information for people and some actual, utility in science, why don't we just look at how things are connected and use statistical smoke and mirrors to make almost non-existent tiny effects look massive by basically misdirecting and using mathematics to fool you, and make it sort of universally acceptable within our fraternity that that's what we're going to do. We're just going to basically misdirect the public and make ourselves look really important. In fact, what we'll do is we'll invent a thing called a hierarchy of evidence and place our epidemiology at the top of it so that our studies are all high level and can't possibly therefore be challenged. And science is settled. Thank you very much. Thanks for coming. We'll take the research grants, even though our research doesn't cost any money anymore, except in computing time and salaries. Maybe the odd statistician to make sure that everything's smoothed over in terms of not overtly lying, just sort of misdirecting in a way that's acceptable. In other words, telling you that the difference between 1 and 20 million and 2 and 20 million is actually 100%. Good. That's what we're up against, and it's driven by people's need to be authorities. It's driven by people's need to financial gain is what I'm getting to, I guess, Troy. It's there are big corporations with millions and millions of dollars at stake who want to influence what nutritional science supposedly says. And so these campaigns of public brainwashing, and that's what they really are coordinated. They are done with malice aforethought, and it's time that we train ourselves to be able to read these studies and do the math, such as I have done for you just quickly on the back of an envelope today.
Thank you very much. So if you're watching out there, someone comes to you and you're sitting, let's say you're out to dinner with your friends, right? Whatever, your family, and you are trying to do the right thing, and you order a plate of bacon and eggs, and you leave the pancakes and the orange juice, and everyone questions you, and they say, well, aren't bacon and eggs going to give you a heart attack, right? Or doesn't? What about your cholesterol? Doesn't cholesterol give you a heart attack? Your response should be, well, it could be many things, but it should be, well, how does that work? And see what they say. Because
I don't know. I'm just parroting what I've heard 100 times myself without thinking about it either. Basically, is what most people would say if they were
really
honest.
Okay. So how do eggs cause heart disease?
Well, help me understand that. Tell me more about how the process is.
When they don't have an answer for you, then you don't have to be mean about it. Just eat your breakfast. Okay.
And then after that, directly after that, you can say, Dr. Garth Davis, thank you for your time.
So yeah,
Good.
so thank you, Bart, for that. I
No,
do
my pleasure,
appreciate
Troy.
that.
Yeah, it's been good
And
as usual.
if someone wants to kind of go deeper down the rabbit hole with these types of things, where can they find you on the internet?
Basically, do a Google search on Bart Kay, Nutrition Science Watchdog. The first 3 or 4 pages will be me
Okay,
of
and I will,
results.
I will put a direct link in the description, so make it easy for them.
So I have a
Uh,
YouTube channel. I have a Patreon where you can either come on as a donator at $1 a month. You can pay $10 and get access to a bunch of more scientific, more training based videos, which are less entertaining, less of me swearing at people and stuff. You could just watch YouTube where I'm just rude and swear at people because it's fun. Yeah, basically that's what you can do. Or you can also pay a bit more if you need consultancy. If you need opinions on what the science tells us about this, that, or the other thing, if you have any health concerns, whatever else. I don't give medical advice. I don't give advice of any kind, actually. I say, in your position, here's what I might do. But that's available too. So Troy will link all that stuff, and I would be very pleased to see you over there. Cool.
all right, very well. Thanks again, Bart.
All right. Cheers.